Hello, so welcome to my presentation about how to test digital twins. My name is Maroš and I'm coming from Košice, from east part of Slovakia, and I'm QA lead, technical lead and Ness digital engineering, and you can see here my contacts, so please do not hesitate to contact me in any questions via LinkedIn or email. Okay, and let's go to agenda of my today's session. So at the beginning, I will speak about definition of digital twins. Then I will mention a history of digital twins, then some industrial sectors where digital twins can be used, some real-life examples of usage of digital twins in the world, and then I will introduce some demo pages where we can see and touch digital twins. Then manual testing of digital twins, and I will focus at automation testing of digital twins. There will be also a demo, and at the end, key takeaways and Q&A session. Okay, so let's start with describing what digital twins are. So digital twin is a digital virtual representation of some entity or state or process which exists in a real world, and it consists of three parts. So first part is physical entity in real world. Second part is digital entity or digital twin is software form, and then we have some data which are coming from one side to the other. And the goal of digital twin or the purpose is to reduce costs, improve operations, enhance innovation, and yes, improve the quality. Let's go to history of digital twins. For sure, you know the movie Apollo 13, directed by Ron Howard, starring Tom Hanks or Kevin Bacon. And in 1970, this Apollo 13 program was launched, and nobody expected there would be any problem. But there was a problem. Oxygen tanks exploded, and then began the famous rescue mission. We know the sentence, Houston, we have a problem. And this rescue mission was successful, and the reason why this rescue mission was successful was that on Earth there was a twin of this spaceship, and they were able to test various options how to fix the problem, and they found the best solution and then applied this in space. So this is like first something similar to digital twins. And the terminology of digital twins was first introduced by Michael Greaves in 2002. And on the conference, he had a session about product lifecycle management. And for the first time, he used this terminology, like you can see on the bottom right part of the slide from his presentation: real space, virtual space, and data and information coming from one side to the another. So now we know what is a digital twin, and so maybe the question could be where these digital twins can be used in which industrial sectors. There are many, but I selected four: manufacturing, automotive, healthcare, and aerospace. So first, manufacturing. So imagine you have a factory, and you have a digital twin in software form of the factory, and you can test various layouts, designs, monitoring, maintenance, or repairs. Or in automotive industry, you can simulate autonomous driving or 3D design of cars, new development, or interfaces between humans and machines. Another interesting sector is healthcare. So there are two parts. Like first part is the hospital. So again, you can optimize the operations in the hospital. But the second part is the human body. So imagine that you need an operation, for example, of your heart, and you have a digital twin of your heart in the hospital, and doctors can, for example, at the beginning, imagine there are 5 or more options how to do this operation, and they can do it first in this digital twin, and they found the best solution, and then they will apply it in real world. Then we have, for example, aerospace. You can have digital twin of a whole airplane, or for example, engine of airplane, and you can test some prototyping or simulation. So we know now what are these industrial sectors, but let's go to concrete products which we can find in the world. So the first one is virtual Singapore. And what is it? So it's a platform. It's a digital twin of the city state. So Singapore is a city, also the state. So all state has a digital twin. And it enables users from different sectors to develop various tools to test some concepts or services, and it can help with planning and decision making. So let's see what does it mean. For example, first area is light and light and temperature, and this digital twin can calculate percentages of light and shadow per building based on the position of the sun and help with, for example, planning new constructions. Or another one application is sustainable transportation and autonomous vehicles, so people can see where are available autonomous cars. Or another interesting area is emergency services. So in case of gas leaks, they can simulate and find best escape routes for the people in Singapore. Now let's move from Asia, from Singapore to Europe, to Rotterdam, and there is a famous port of Rotterdam, and also they have a digital twin. It's called Digital Port of Rotterdam. And till 2030, they want to introduce autonomous shipping in the port of Rotterdam, and digital twin, or this digital port of Rotterdam, will enable this improvement. And basically, it consists or incorporates various types of data, like weather conditions, movements of the ships, and some infrastructure objects. And again, the goal is to reduce waiting times and optimize loadings, departures, and so on. So we can see it's already applied in many places. Now, okay, we have this digital port of Rotterdam, we have virtual Singapore, but we cannot play with it. It's not available for public. So what we can do, like the testers now, for example, today with this, there are a couple of demo pages which we can look at and play with them. They look like real applications, but the data are fake. This is one of them. It's an engine, and you can see that on the left part you see the model. So this is basically how digital twins application look like. You have some visualization of the entity. You can rotate, you can click on it, and on the right side you can see the data which are coming from a real device, depending on which part you click. I will use this one also in my demo for automation testing. The second one example, another web page is a solar energy field. So again, some web page where you have these solar panels, and you can look at different panels, click on them, and again, you see the data which are coming from these entities. So now we know what are these digital twins, and let's think about the testing, how digital twins can be tested. And first, manual testing. Okay, so you have some data. Okay, we can test the data. We have the model. We can look at the model. We can do some analysis. So regarding the data, this is important that our digital twin has correct data. So in a real entity, we have some sensors, so we can look at the values from the sensors on the device, and we can compare if in digital twin we have same values. Then we can do verification of or validation of the model. So verification of the model means that still this digital twin is a software. So when we are testing software, we have some requirements, we have some specification, acceptance criteria, which we need to test. And validation of the model means that we will look at the real device, or entity, and we will see if all the parts which we have in software form are same as in the real world. Then we can do some analysis, for example, sensitivity analysis or uncertainty analysis. So we are checking the outputs according to inputs which we change in different ways, and we can test the reliability or robustness of the system. And again, this digital twin is usually some part of bigger system, and in a real world it's connected, and also our digital twin should be should have also same integrations with different systems or communication or have compatibility. And again, depending on the industry, we need to validate the standards and regulations like data privacy, security, and compliance. If we now go to manual testing of digital twins, I was thinking to use some simple solution or a simple project. So I decided to use Robot Framework and Visual Studio Code, which has very nice plugin for Robot Framework. And when interacting with this demo page of engine, we have in Robot Framework two options, Selenium library or Playwright library. And I was thinking about this left part. You see this model with some animations. So here I decided to use a Kutschy library, which means that you first create some images of your application, store in your project, and then use some keywords, and Robot Framework via this Kutschy library will click on these images on the page. And also I decided to use Applitools Eyes for visual testing. I will have a demo, and the project is on, or repository is on GitHub. So if you would like to try it and play with it, it's available under my account. So you can look at it and play with it. Please, let's now move to, I have a pre-recorded video. So yes, please, let's start it. So this is the project in the repository, and libraries which are used, as I mentioned, Selenium library, Playwright library, Kutschy library, and Applitools Eyes library. And regarding the prerequisites, what you need to have on your computer, so you need to have Google Chrome, you need to have Git, Visual Studio Code, Python, needed by Robot Framework, and also install a plugin for Robot Framework in Visual Studio Code, and just install Robot Framework and all the libraries via simple command. So setup is not so complicated. If we want to use Applitools Eyes, we need to create an account on their side. And when we create the account on Applitools Eyes page, we just take API key from our account, put it into a YAML file, which comes from creators of Robot Framework library. And this is how our computer will be connected with our account in the cloud. And installation is simple, just clone the repository and open robot files. There are two robot files, and just run any test case in these robot files. So this is about the setup if you want to play with it. And now let's look at the application. So this is our application under test. As we can see, we have this model on the left side. On the right side, you can see some data coming, and some tables. So right part is simple. It's very easy to identify the elements via IDs or XPaths or CSS and use it for Playwright and Selenium. So this is straightforward. Regarding this left part, you see it's not so easy. It's some canvas part, and yes, some elements or some buttons in this model can be identified, but this engine is not so easy. So here I decided to use Kutschy to interact with this part of the application. And yes, we will see in a moment in Visual Studio Code. So this is IDE, Visual Studio Code, and two files. First one is robot file BIP Selenium and Sikuli and Applitools eyes. So the code, yes, it's still code, but you know, robot framework, just some keywords. So no coding is needed if you want some simple tests. So at the beginning, you just specify the libraries, Selenium, Sikuli, and eyes library. And then you specify the place where all the images for Sikuli are stored. And you have test setup like before method, something like this, which will run before each test case. So we open the browser via Selenium, we navigate to our web page, and the first test case, click on this model on the left part. So via Sikuli, so you just use Sikuli click keyword, and as a parameter you pass the name of the screenshots, and all the screenshots are stored in our project. So these are the screenshots from our application, and they are part of our repository. Okay. So this is about the steps. So now let's see how it is working. So if you know robot framework, it's easy just run the scenario. And yes, you can also with the screenshots do some validations. For example, if the screenshot is there, and just run the test case. So as you can see, for this simple scenario, no coding is needed. So very quickly you can have the test case, and we have started our test case via this plugin for robot framework, and the application is browser is started via Selenium, and we can see that our page is opened, and these clicks, which you can now see, are done via Sikuli. So Sikuli found the screenshot in our project and compares if it's in the application, it can click on it, or you can also type there or do other stuff. You use other keywords which are coming from the creators of Sikuli library for robot framework, and the results, again, out of the box, this report is coming from robot framework. So if you open the results, you can see the keywords which were, or the library of each keyword, and also in case of Sikuli, you can see the screenshots as a part of the report. Okay, so this was the first test case using Sikuli. Now imagine that you have this application which has the model on the left, some data are on the right, and how to do validation. So first option is write many validations for everything, or another option is just do one validation, one step which will check all the page. So this is where Applitools eyes or visual testing tools come in place. You have just one keyword for opening eyes, second one for doing verification, and you just close one. And this is Applitools eyes UI, where you will see the results of your visual testing. So now let's run again the second scenario, and the browser will be opened via Selenium. We will see it again, and yes, we navigate to our web page, and next step is we open the eyes, and now we are saying to Applitools, let's check our application. So when you for the first time run the test, it will create a baseline screenshot, and each next time when you run the test, it will compare actual screenshot with the baseline screenshot. But all this magic is happening on their cloud, so you don't store any screenshot on your computer or in your repository. Everything is on the cloud. Just one mentioning, you have 100 screenshots for free per month, so you can do some quick POC. For more, you need to pay. And when test finished, already this validation was done. So you can see if the test passed, it means that validation was successful. If validation on their side was not successful, you can see it failed. And in the robot framework report, you see the link on your results. So you just click on the link and you are transferred to your account, and you can see the comparison. So you can see the baseline screenshot, you can see also the actual screenshot. In this case, it was the same, but in case you have any differences, it will be highlighted here. And yes, for visual testing, there could be separate session. We have more tools. Also, as Marcel today presented, Whoopi has something in offer. Also, Percy from Browser Stack. So there are more options to choose from. And the last test case is the alternative. So if you don't do this visual testing, you need to write validation for everything. I didn't wrote for everything, just for some of tests. But here you can see the benefit, for example, for using visual testing, that with one step you have tested everything. If you don't use it, you need to write many validations. So I'm using just pure Selenium in a last test case where I check just some text of the elements on the page. And it's quick because, yes, browser is opened and validation is done. And in the report, then we can see the results of all of these validations. And you, in the keyword, will see that these keywords are coming when we refresh the page from Selenium library. So this is Selenium, and I was thinking if the same approach can be done with Playwright, okay? Because you have two options in Robot Framework, Selenium or Playwright. Playwright library is called browser. So browser library in Robot Framework means Playwright. So in a second robot file, there is again Kutschy library, and browser means Playwright library. So test setup, which will run before each test case, is similar, but now we are opening the browser via Playwright, not via Selenium. And I was wondering if Kutschy will work with Playwright in Robot Framework, as Playwright and Kutschy has same click keyword. I needed to specify the name of the library, and again I used same images. We are running the test case, and browser is opened via Playwright, and then Kutschy steps will come, and we can see it's working. So again, Kutschy is clicking on the elements of the web page according to the pictures which we have in our framework. So if you want in Robot Framework to use Kutschy, for example, for testing digital twins, you can choose if you will use Selenium or Playwright. Unfortunately, the Applitools library in Robot Framework was not working with Playwright. It required Selenium. So I don't have this second test case with Playwright. But I tried to do the last test case where I just identify the elements and do the validations of each of them. And in comparison with Selenium, there are different keywords or different maybe approach how to do it, but it can be done also via Playwright. So I identified the elements and then checked the text of the elements. So again, it was working. It was working fine. So like the outcome, yes, Robot Framework was very easy for me how to use with testing these digital twins. You can combine various tools. As you can see, no coding for this simple test is needing. You just write the keywords, and very easy. I like the Applitools approach. That you don't need to some coding or some special setup for this visual testing. Also Kutschy is very easy to use. Okay, so thank you. We can go back to to presentation, and just the last slide about key takeaways. Okay, so for me, this topic of digital twins was very interesting. I hope at least it was also interesting for you. And I found many videos and many articles about digital twins, but not so many about the testing. But I think testing of digital twins is also very important. And at the beginning, I was wondering if automation testing can be done, but yes, it can be done. I focus just on UI, but yes, you can test also API or other parts of digital twin. And what could be now? So just we should study digital twins now, and let's be prepared for the future, because I think in future we will see very often digital twins in our testing careers. And that's all from me for today. Thank you for your attention.
So thank you very much, Maroš. And now it's time for questions. So please log into Slido or just raise your hand, give us a sign, and you can ask live. Okay, don't worry. It's we have a question. Thank you. Oh, there are more coming. Perfect.
Should I read?
Yeah, we have a question. So
the SQL library, is it open source or?
Here. SQL library, yes.
And is it possible to use it without robot framework, or is it dedicated only to a robot framework?
It can be used, yes. I'm not using robot framework at work. I'm using Java Selenium Cucumber framework. And we also have done POC for SQL. So it's just a library which support various programming languages, or you can, if you have Maven Java project, you just add dependency. And again, if you are using Cucumber, you need to write some step which will use this stuff, and then write it in Cucumber. In the robot framework, very easy. You don't need to write any code. You just import the library and write, click name of the picture, and that's done. So open source, and it can be used in many frameworks, languages, and so on.
Okay, and just small comment. Also, Playwright is offering the visual testing, as far as I know. So you don't have to use the apply tools for that.
Playwright. I am also not using Playwright at work, so I was just using it now. But as far as I know, yes, you can do some visual testing, but maybe you need to store. So there are many tools on the market, or open source tools for visual testing, but I think you need to first create a screenshot, like for SQL, store it in your project, and then maybe some Playwright add-on or some other tool will do the validation. But the power of these visual testing tools, like Applitools Eyes or Browser Stacks Percy or Whoopi, what Marcel today presented, is that you don't care about management of screenshots. You just say, now I want, so you have some test case, and after step 10, in step 11, you want to add a visual check. So you just write visual check, and the screenshot is stored on their cloud. Also, this comparison is on the cloud, and the report is on the cloud. So you see everything there. You don't need to manage it. So I think this is the power of these tools, but yes, it can be done also in other ways.
Okay, thank you. Yep. So we have more questions from Slido. What type of bugs are the most common found via this kind of visual automations testing? Can you automate process in digital twins?
What type of bugs visual testing? So again, it's similar, like today it was presented by a guy from Multitude and from Whoopi. For example, if you check just via Selenium or Playwright or Cypress, if some element is there, okay, it can be there, but could not. Maybe it's not visible. So this could be one bug, or another bug is that some font is different, or maybe some element is overlapping other element. Okay, so again, via Selenium, you will just see if element is there. But so all the types of visual problems which you cannot do via some basic Selenium stuff. So these are the type of bugs which can be found via visual testing. Or imagine, for example, at work we are using, not Apply2Eyes, we are using Percy from Browser Stack. And we have like an internal application which is storing all the elements. And we are using this because there is no functionality, just storage of some elements which are reused in real applications. So this is another good application of visual testing.
So next question. What cloud service do you use?
Cloud service, you mean application? Application is using also AWS, also Microsoft Azure. But if you are thinking or asking about cloud for testing, so or maybe some servers, we are not using a Lambda test or tools like this. We have our Jenkins nodes on-prem. So I'm not sure if this was the question or if you're meaning something else.
Raise your hands. Who asked the question if you need more details? No? Then probably they are happy. So, okay, so what is the main difference between testing digital twin applications and other data model applications?
Yeah, so for digital twins applications, maybe if you compare with some standard applications, I think the difference is that you have this model, which is maybe more complicated to interact with automation testing. And still, I think you need to compare also. This manual testing is important to check if this model is in compliance with a real entity in the real world.
Thank you. Any other questions? Or Slido questions, live questions? Nope. Okay. Yes, we have a question. Wait a second. You get a mic soon. Give us a second, please. Marcel has a question. Yes.
We have some experience with Sikuli, and I would be interested about your personal experience in real life, how it's stable and how do you like the way applying this type of approach that you are basically identifying the elements based on pictures. Because this is a kind of, I would say, old new idea. So I would be interested about your personal experience, whether you have some or whether you have only the demo experience or you have the real project type of experience with Sikuli specifically. That would be something interesting for me.
Yes, for Sikuli, we have done a POC a couple years ago, and we were able to automate test case from the beginning till end. So we logged into application, we typed everything with Sikuli, and it was working. But we never get to the stage that we applied into our regression. So we tried it. Also for this demo, I played with it, but we are not using Sikuli like for daily. But I think there are more tools. For example, if you, for example, need to download some file, you need to go outside of the browser. So there could be some use cases where there is no other option. So I would not rely on it in general, but in some special test cases, some edge cases.
Did it answer your question? Yep. Any more? 3, 2, 1. Okay. Thank you very much. Maroš, thank you very much.
Thank you.
Thank you.